All right, so today we will just try to crack the program we write in C language. This C language is used during a disassembly, so this is why I decided to write this directly in C. And the idea of this program is very simple. It will be the exec program. So exec is like every program you have for PC. And it is written in typical C, not C# and not in Java. So it is compiled to the full exe file and not to the middle state, like special language like Dalvik, and then compiled finally when you start it. No, it will be just a really real exe file, so much more difficult to analyze and to reverse engineer than the Java file or C# file. All right, I continue. So this will be the exe file. This exe file, of course, can be open in the WinOls, and we can open it also in IDA or Ghidra. So here I have WinOls, I have Ghidra ready. It's Ghidra 11, and okay, let's put the Ghidra to the side. And I have also IDA free version. You can just download it directly from Hexrace page. So, and we need a programming language. So I will start now C Builder. So as I told, it is producing the hard exe file, not a language, mixed language like C#, like Visual Studio with C#. So it's harder to analyze. Okay, I just change the size of this application as it's slightly too big for the screen. I'm afraid I need to do this twice. Okay, so at this moment I start building a new application. It will be a Windows visual application, so just application with Windows, let's say like this. So we are starting the new one. Okay, again, I must change the size of the builder. I do not understand that stupid behavior of that application, but it is like this. All right, so first let's plan where we save the application. So this will be saved in, let it be my desktop. I will just make a Coders Club. And inside, I will just make a folder for program. And I make another 2 folders for IDA. So here we will reverse this in Hydra, and we will reverse it also in Ghidra. But now I save the program. So this will be here, written in C++. I can start it now. If I start this now. Okay, so it is just compiling it. It's empty application, yeah, it does nothing, but we can see this like this. I can just close it, that's all. But the application is ready. Now I will add few controls. First will be just the place for text. edit one. Okay, and I clean the text which is inside. Text, it is field text, so just put nothing. And this is the edit one. Okay, now I take another edit. This will be the answer of the system, edit two. Now I just remove also the text and I make it read only. So we can use this only to read, but we cannot type here. And we need one button. That will be all. Here is the button. Button one, and we write the text check. Check password. So if I press this button, I will be checking the password. Password should be typed here, and the answer of the system will be here. That's all. Edit one is for my guess of password. Here will be the answer, yeah, good or bad or something like that. And check password, it is a button. So again, if I just compile it, I will have this. So I can type here, but I cannot do anything here. And if I press check password, nothing happens. So now, of course, we must write the code. So I double click this. And now in C language, I will type. So first, let's take the information of what I try to guess. So this will be attempt. Let's name it attempt. So I just write simply that's a string attempt should be edit one, and this is the field inside the edit one named text. All right, so now the text which I type in the edit one will be put to the string attempt. So now I should just have a password also. So let's write the password. So this will be, we will use the word Ghidra as a password. I add here a comment. Ghidra is a password. Okay, so now I just build the password. So this will be six letters. And these letters are, okay, let's check these letters. I will just go to WinOls. Yes, I simply type here as a text in any project, does not matter. I type Ghidra, G. That's all. So here I have hex values for that. As here you see at the top, it is hex. So it will be 0x47, 0x68, 0x69, and so on and so on. 0x means that it is hex, hexadecimal. The same is for Ghidra, the same is for IDA typing. So nice to remember the method of telling to the system that the value is hex. And the end of the line is semicolon. So now we have our password. Let's check if the password is good. So I will simply use if. If is a conditional decision. I can just check something and then decide if I should do one thing or another thing, for example. So if the password, so if pass equals, notice that the equalization, it is twice equals, and this is just moving these values from right to left. Okay, so if pass is attempt, then for sure we can write that the password is good. So I just put text to the text field of edit2. And so let it be good. Good. That's all. Okay, and if not, so I just type else. So otherwise. Of course, I will just type something like wrong. So I just copy this to type faster. Is here should be wrong. Try again. All right, so I save this once again and I start this. Let's check. Okay, here we have our program. So now if I just type anything and check password, so this will be wrong. And if I type here Ghidra, okay, if I just write Ghidra1, of course, this will be wrong. So now let's try to see this program first in WinOls. So I just go to place where I have this program. Okay, just a second. It is at my desktop, yeah, desktop. You do not see this, but it is just at the screen. And program, and it is just, of course, I will give you all of that at the end. So, and now I will open this in WinOls. So I just close this, and I drop project to WinOls. It is not a car file, it is exe file for PC. So for sure there is no checksum for that. So I name it exe for Windows. Okay, the first question is it easy to guess the password or find the password directly as a text? Let's see the text inside. There is a list of the text. Okay, so we know now the compiler, but as you see, the text Ghidra exists already inside. I can find this. So I can guess that this is the password. So of course, the cracking will be very easy. Let's improve the program a bit. Let's make it more complicated. How can we do this? I will do something like that. I will change this to this one's down to 46, this up, this down, this up. Yeah, and then this down, this up. So of course, the text is not Ghidra now. So now if I just compile this program and what's happened? It's already running. I must close it first. So if I start this program and type Ghidra, now the password will be wrong, of course. So to correct this, I will add 1 to the first value, and I will do -1 to the second value. It is in C. It is like this: pass position 0. This is the position 0. ++ because I have reduced the value, and then the same for other lines. 2, 3, 4, 5, 6, and here is 1, 2, 3, 4, 5, and here should be for sure minus minus, minus minus, and minus minus. Okay, so it has improved. Save again. I start this again, and let's try now Ghidra. Is the proper password? Good. Okay, is the text of Ghidra inside the program? For sure, no. Let's check this. If I drop this, it can be even a version of the old program. Now the Ghidra is coded. Simply coding, but of course now it is VHAQB. It is not Ghidra. You cannot find the proper text inside. Okay, so we have a nice application written, and now we say thank you to WinOls, and we just go to Ghidra maybe first. All okay until now? All is okay until now?
Okay.
Okay. To be honest, I see sometimes strange video, Stanislav, so from your side. So maybe switch off the camera or keep it switched off. Okay, so first Ghidra.
This is no my camera. Użytkownik Zoom.
It's another person. Okay. All right, so I simply start a new project, non-shared project. I name it execracking. And for this project, I import file. I will drop this file. Simply drop it here. This is what I have received as a result of the compilation of our program written in C. So now I simply press OK, and importing starts. Also, if you compare Ghidra to IDA, IDA is written in C, like our program, and Ghidra is written in Java. And this causes that Ghidra has much lower performance comparing to IDA during disassembly. So somehow IDA is faster in such processes. All right, so I just opened the analysis. So I press yes and simply analyze. We are at the entry point to the application. I will move this to such position. And here we have a C code. Now it's not the function we are interested in, but it is trying to disassemble it and change it into C language. And also we have the function grapher. I just make this function grapher slightly smaller here. And the function grapher will show us what's going on, how the information flows inside. Okay, so now, for example, I will start from seeking any known text from the application. So let's start this application again. Here it is. So for example, this I can search for, text check password. This I can search for, because this I know. So let's try to to seek for the word wrong. Okay, so I just copy this and I search here. So direct searching, if I just go to search and look here, here we have the results. This won't work for sure. Because why? This text, the text wrong, will be directly visible in the text of program only in one situation, if such string is detected and understood as a string. For example, here we have a word hook. Yeah, this is C++ hook, but the disassembler is not understanding that this is exactly the string. If the disassembler finds this as a string, for sure it will present it here in the one line writing C++ hook, but now it is not yet found. So direct searching won't work for us. Even if we search for all fields, simply won't help. So let's search the memory. We can search the memory just typing the string here. So we're on wrong. Again, no success. Maybe we have hex values like this. So I just simply switch to that, and I need to search for. First, let's see this in WinOls. So this is the text wrong. So I simply copy here. Now back to Ghidra. Sorry, here hex again. I clean this, paste, and search. Does not like us. Let's try other text. For example, edit field. Somehow hanging for a second. Oh, edit string exists. If I'm not sure if such names as a field names exist, I can use following program. This is the program which is named just a second, what was the name of that? PE Explorer. It is a very old program from Heaven Tools, and it has no limitation, to be honest, because it has a bug that the time limit of 30 days never blocks you. And I drop again our exe program here. So here, if you just go to this resource monitor and RC data, and then to the form, you can see what are the names of the controls. So edit 1, edit 2. PE Explorer, remember. Okay, so I have found the text, but see, it is still nobody is asking for the text. Here, button one click is detected as a string. This means it's detected as a string, but nobody asks for that text. So what's happened? Oh, even the text wrong, try again exists, but nobody asks for it. Nobody needs that text. There is no function that uses that text. In that case, it means that our disassembly is improper. Let's improve the disassembly. If we just go here to analysis, and let's try to use aggressive instruction finder. So If aggressive finder finds some functions that are asking for the text, then it will be a reference here. So now we are happy. We see the reference. Even we see what is the answer if we are okay, if it is all good. So now I simply click to this or this reference. We are moving to some function somewhere. Here we have how this function looks like, but we can use the big graph here. Yeah, so even it starts here. Yeah, every PC function starts with pushing the registers, some registers to the stack. It is just preserving of the value of the registers. So we can even press the function button F here and change this to function. So now it is really the function. And let's correct this view because it's something happens not especially nice. See, if you just go here, you can just change from nested view, which is not always good one. Nested, it is just following the flow of the data as it is in directly in assembler. But sometimes it's difficult to understand what's happening inside. So I suggest you to use the compact hierarchical. So now we see that this function, it starts here, yeah? Always if I select something here, it is selected on the other side. So it starts with some preparations and calculations. So we can think that, okay, this password, it is calculated here. As you remember, it is not a very simple method because we have used that trick and the password is not existing as a pure text inside. At least it is not the text Ghidra. All right, so let's go back here. So going down, 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 we see that there is only one decision because blue means simply jump from one point to another point. No decision. It is just flow. And we have only one decision, red or green. It's here. Okay, let's check now which is good, which is bad. I just go back to the view where I see the texts. Here you can just go back to the former view or to the front to the next location, next view. So for this text, which was good, we were in this area. Here the text good is needed. I just select this line. So this is this block. Here, it is here. So I change the color to green. So I remember that it is this side. And where is bad? I do not see it here. So I go back to this view. I double click here and it is this side. So I change the color to red. Oh, pink. Let it be pink. Pink is bad. Okay, so now it's very simple to understand the situation. I don't know what is the password, what the password is. But if it is good, we go to the green side. If it is bad, we go to the red side. Okay, let's manipulate this. So decision is exactly here. J and Z, jump non-zero. This test tests the value. And this jump, it is this if. If we just go to this program, this is this if. This is exactly this text. Let's see how it is disassembled. If I just go here, okay, I say thank you to the compiler. And at the graph, I go again to the decision. It is here. And now I go to C presentation. It is here. So if I click this point, I can see until which point the operations inside are one type of operations. For example, as you see, they are red. So this is for wrong decision, wrong password, and this ends here, starts here, ends here. And then it's opposite situation. From here to here, it's a green area. Good decision. You see the text, good here, and wrong, try again. And address where it is located, because it is just a mechanism how the Ghidra shows the addresses. All right, so now it's not bad. We understand what's happening. We understand that this if is this test. And as a graph, it is exactly that point. So let's try to change this to opposite value, opposite side. If J and Z is 7505, what is JZ? I just go and patch instruction. Okay, we wait for compiling the assembler. And now let's do this. It will be 74. Okay, theoretically, I can just press enter and have it ready, but I would like to do this in WinOls, because I try to teach you some mechanisms of work we will use in next lessons for cars. So now I do not press enter here. I only remember that I should change 75 to 74. That's all in this point. Okay, so now I just simply open this application in the WinOls. Here we saw my WinOls. It is even now opened here, this version. And I search for that point. The addressing can be different. Every time we have a trouble of proper addressing. So I do not readdress the values here and look for the address, but I will just simply look for a string or for set of hex values. So I go back to the to here. I add this view here. So now I can just select, let's say this, including few operations earlier. And here I can copy the data, not here, because this will be the text copied. So you must copy from that side. And now I go back to WinOls, Control F, paste, Control V. So there is one occurrence of the text. It's simply here. Maybe this view is not clean, so I will just open the new version of that. Okay, so I just close this and close this. And I open this again from compiler, finish immediately. I search again. There is one existence of the text. It is here. So this is the 7505. I have no trailing zeros here, so this is why it looks like this. So this is exactly the two values we are interested in. So as you remember, we should just change this to 74, which will be the opposite decision. Yeah? And now I export the file. So I just simply export this. So I name it cracked one. Binary file without checksum. And now we are just working at the desktop. Where is the desktop? Here. So this is the Ghidra, and I name this password Ghidra. Exit. Ready. Okay, so I open this program. Okay, I will show you. I just go to this password Ghidra. I start this exa. It's here, and now I type the password blah blah. So this is a good password. Of course, if I just write here anything else, it will be also a good password. Of course, if I write Ghidra, this will be the wrong password now. Surprising. Okay, so as you see, we have cracked that. Only problem is that we do not have the information what the password was. I know the password, but I know the password because I have written the program, not from that program. So let's try now to do the same in IDA. Because in Ghidra, we can try to emulate the program, but to start the Windows program, you need to build everything else, emulate complete system. So you must configure debugger, or emulation won't give you the answer what's happening. So you must analyze the code step by step, or use another tool. For example, we use now the IDA. So now we are moving to IDA. Okay, so as you see, the Ghidra helped us to find a proper location and to manipulate this value. If you just manipulate the values here and or directly here, you can also type here. And you would like to save the binary, it is here, export program, and here you must just select row bytes. So now we will export the binary like from WinOls. Okay, so next attempt. Give me just a second for water. IDA. Okay, so I simply drop the exa here. So this is the no, it's not this. It's here, 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 exactly this one. Yes. For security reasons, I started and I checked that it is not cracked. It's not cracked. So I simply drop it into IDA. As you see that you can choose the various microprocessors, or just Meta PC means universal. So I just leave it as it is. Again, I must just change the screen. So as you see, the IDA prepared slightly more information for us, even the name of the forms, and we can find even the elements. For example, if I just look here for button, sorry, not here, here. Control F button. Yeah, so we will find various functions which have a button in the name. The pink one, it is just the system. It is brought from the system libraries. The white one, the only white one, it is written by us. It is our program. If you just check this, you see that there are various colors. Yeah, this is all from the Windows system, and the white are are written by us, delivered from our program. Okay, so I just continue the same way. So now I simply go here, as here is a button click. Here I have hex view, and I can also open the graph view. So here our function starts when I click the button, and let's compare it with Ghidra. I keep Ghidra open so I can simply go to the same point in Ghidra. Yeah, it's here. But we have created that function. As you see, the IDA is ready with that function and found that this is the function which is invoked after pressing the button 1. So then we have a data flow here. And again, as you see, the methodology of colors is the same. And this is the answer no. Yeah, so this will be wrong. Notice that everything is already decoded. So here IDA shows the real power and the opposite side, which is good. If I would like to change something here directly, it is just not right button here. This won't work. You must just go to Edit, Patch Program, and Assemble. So now you can 3D assemble. So simply change J and Z to JZ, and everything will be opposite. Yeah, and cancel if you don't want to code anymore. Okay, I just make it back. So I just go Patch Program, Assemble, J and Z, and escape. Well, all right. So I understand that I have found the proper place. I can just identify this in this view. So I know the address. I can search in WinOls for such line or something like that. Just Control copy and then search. So for sure, I do the same what I have done in Ghidra. But now I will try to learn what is the password, because the password is coded. See what I do. I will stop this program at the beginning of this function using a debugger. Right mouse button, I leave the breakpoint. Stop here. When you just start the program, please stop here. And now I will start this program using the debugger, which is the local Windows debugger. See what will happen. I start the process. Yeah, okay, again, I need to do some operations with Windows. Yeah, and here is our program. It's working, but it's working under the control of IDA. All right, so now I prove that this is not cracked version. I type anything and check password. I cannot see the answer because I have asked the IDA to stop the program at this point. So it is stopped. Okay, let's see what's happening here. If I hover over any register, I will see what is the value or values, because sometimes it is just a long part of stack here. In tricore or renesas, it will be much more simple because there will be shorter registers with size of 32 bits or something like that. And now pressing F8, it is common for every language, F8. Here, see, debugger, F8. step over. So do one step down. So now my program goes slowly under my control. I can, all the time, I can check what's happening. And where we are going to the point where the decision is here. Okay, I just go back. See, this is just a conversion string to Unicode. Because I press F8, the debugger is not going inside the calls. If I press F7, it will go into every call. Call, it is just call to subfunction, but I'm not interested in that. Probably the coding happens here. Let's check what do we have here at the stack. We have something like FIHEBQB. As you see, the bytes here are rebuilt one after another. Yeah, they are disappearing from the stack. So what does it mean? This means that they are now this part of our work. Yes, wait a second, I will just look for its video. So now this is happening, this line after line. So soon I should have the password. Let's see if it is true. I hope you see this. So now I see the password. The password will be Ghidra. And so this is the decoded password. And if I go further, okay, so now a few operations happen and it goes here. Of course, these functions are reading the value you have typed also in the edit field. So this is why we have more operations. And now at this moment, it happens the comparison. And of course, we will see blinking answer. Answer is no. Yes, that's true, because my password was wrong. All right, so this is just an example what IDA can do for us here. We can start and control that program in the debugger, and the program thinks that it is simply running. So somehow better. Okay, I now go back to IDA, and I will just, back to Ghidra, and I will check what will happen if I try to emulate that function. Because here, as you see, using debugger, we can simply control step by step the program and find the password without guessing. We simply read the password from inside. And this will be useful for breaking checksums in microcontrollers. This will be useful for bypassing the ecology protection, something like that. So understanding the method of working with changing the rule which is blocking you to opposite is very crucial. Very good method, because you do not need more code, because the size of the code stays exactly the same. And by changing the rule, for example, they have a rule: if it is non-zero, change this to jump 0. If they do jump equal, change it to jump non-equal, and so on and so on. So just by changing one byte, you can just bypass the various protections. Here we are bypassing the password. Okay, if it is understandable, I will quickly ask you if you are not sleeping. Shit, where can I see you? Are you here, alive? Hello? Anybody?
Все понятно, все
It's
понятно.
okay. All right. So I go back to Ghidra. So thank you, Ida. It's still running with that application. It is frozen because it's under the control of Ida. So first I go to Ida, I stop the control. So now I can close all these applications. Okie dokie. This is to be removed from the screen. So code browser. So now is a question, okay, are we able to do the same here? Are we able to do the same here? To be honest, at least not with a simple attempt, because see what will happen if I try to simulate this. I save this at this moment, and I open exactly this in another option we have here. I open this in emulator. So I will try to emulate this. I open again this project, and even I can go to the same place. So I just go to the code browser. I copy the address, control copy, and I go back here to emulator and I press G to go, paste, enter. So this is our function. Here, of course, it starts with it starts with pushing the registers to stack, and then this is this section. This is the section where calculation of the values happen. Let's try to emulate what will happen if I just start from this point simply. So here I go to the debugger and I just emulate program in new trace. All right, so we are at this point. We see all the registers here. And now, of course, the step is F8. Everybody uses F8. So here also F8. So I slowly do the same, like in IDA. The change, if something changes, it is red here. If you would like to monitor some registers, you must just choose them, so they will be on top here. Otherwise, they are just alphabetically or simply as a producer of the debugger set them. So I slowly go to the direction. And now the first trouble. We start another function. Okay, so I go to that and go back. And now we start the function, which is the function which takes the text from the edit one field, from this field, from this one. Okay, but it is not running. We are only started and emulated the one function. So now it's a trouble. We cannot work like that. So what we should do in that case, because we will have the same cases all the time during working with ECUs, we need to prepare something like IDA did. IDA started the application and took the control over. So the application was controlled by IDA in debugger, but all the secondary parameters, window sizes, fields like edit one, edit two buttons, they were generated. They existed. And here, if we emulate like this, there are a lot of unknowns. For example, this is unknown. This field is not existing because we only emulate one function. So in that case, we will solve that by Control-R. We can just change the value of any register. So for tricore, of course, we will change the value of address registers or data registers. Here we have much more registers and parameters, of course, but I'm not focusing here. I don't want you to focus to be hacker of applications for Windows, because we are rather thinking about cars. So I do not go in deep here, but we will just change the values of any register or any parameter which is unknown to be known in the area controlled by us. So we will simply tell him, starting from this point till, let's see, till the end of the function. As you see, this is the selected area. This register has such value as hex or as you want. So using that method, we will build the opportunity to bypass such problems that some values are unknown, because we will prepare them prior to emulating the program or prior to analysis, to improve the result of analysis or to improve the possibility of emulation. So you will see that the tricks used in this lesson, we will widely use in tricore or renesas hacking, or PPC, PowerPC hacking, because they are common, universal, and I believe that they are simple. So changing the decision to opposite, which needs 0 additional bytes, no additional bytes needed to code that, and building the values of unknown values using the selection of the area and Control-R to change the registers. You can also change the registers here. Yeah, it is just here you have all the registers, so you can change them or control them here. Okay, I will now switch to the normal screen, and maybe you have some questions. Wait a second. Stop showing the screen. All right. Any questions?
Okay, I think I would have one. What about when we want to maybe swap the function, or this is not the point of today's meeting? I mean, wrote inject some custom function into the code we already have.
Daniel, in that case, I will just jump out from the code, because if you do not jump out from the code, then you have no free place for your code. So
actually,
yeah,
maybe just wrong question, because I was thinking when you have this checking the statement, we want to, in this case, when we change the register for the operation in the processor, I'm not sure this is the correct one naming, but we are just swapping the condition. But if we want to do that every time we want, just
every time procedure passes to the point you want.
Yeah.
Let's do this. Of course, we can just do that. This is just another approach. This approach. Okay. Well, let me start sharing the screen again. I hear, Daniel, from your accent, you are Polish.
Yeah, we already wrote some emails between us.
Okay. Wait a second. Share part of the screen. Share part of the screen. Do you see the screen? Yes?
Sure.
Okay. So we are at the same function here in code browser in Ghidra. So here is a graph on the side. Here is the decision. And the question of Daniel is, can we just avoid passing the code to other side by changing the rule? but we prefer just to pass the code to the place by force. It's very simple. Of course, we should just jump to that label with a short jump. So it is just this jump. Remember that in that case, if we jump instead of J and Z, then this part of the code will be off-ranked. It is not used anymore. So if you are just doing a clean analysis and then clean work, you should just select all of that and change this to NOP. Or if you would like to make your code to be more difficult for analysis, then leave it. See what will happen. I will change this J and Z to simple jump to this label. So to avoid problems with the label, I changed the name of the label to be good decision. Oh, maybe good is enough. I add here underscore. So my label now will be at the list of labels. See the left side, should be somewhere at the top. Oh, Ghidra hates me and my labels are not shown here. Usually the label will be here, or I hope it will be presented here after a short time, because sometimes it is like this that you must wait for the information. Okay, so now we have this J and Z good and good. All clear. So I just simply assemble, and this will be now not J and Z good, but this will be just JMP. Yeah, in that case, good. Of course, I should replace 2 bytes for 2 bytes, so I choose the short version. So now it is ready. So this jump is forced, but now the graph is not updated. To be honest, I press this to update it. And what's happened now? So as you see now, the jump is, there is no decision. It is just a normal flow. And the bad side here, it is hanging. Nobody is pointing to that point. So the left side of the code is now off-ranked. It is not working anymore. Nobody jumped to that. And the program will accept every password as a good password. So I hope, Daniel, it was the answer for your question.
Yeah, and I can extend this question. And when we already said the old code we should change to the NOP, then in the case of the ECU, we're just getting some free space for our custom code if you would like.
Yes, I usually use such off-ranked areas as a place for my code,
Okay.
my coded maps, for example, or some parameters. Let it be the RPM of launch control or something like that.
Okay.
So it's a lot of free space then, which is inside the code, the main code. So this is a very good place to hide something.
Okay, thanks.
All right. So any other questions, friends?